Hello everyone, I welcome to you all to Startup Academy, your online gateway to success in ISS exam. In the previous lectures, we have discussed our statistics paper 3, which is the descriptive one, and we were discussing the topic econometrics. We have discussed simple linear regression model, multiple linear regression model, and some problems relating to these models. Now, since I told you in the previous lecture that we will continue today. Now continuing the problems with heteroscedasticity in today's problem. So we were discussing the detection method. As we have discussed yesterday, three methods, which were drawing graph between residual and yi's, drawing graph between residuals and xi's, and Breusch-Pagan test. Now today the last test is today the last test is Spearman rank correlation correlation test. This test is very easy as compared to the other test, and in this test can be used for both small sample and large samples, and is comparatively easier than the other test that we use for detection of this method, this heteroscedasticity. So let us consider a model. Let us consider a simple linear regression model, which is yi is equals to beta naught plus beta 1 xi plus epsilon I for all I goes from 1 to n. Let us consider this SLR model. So from here, we will take steps. Firstly, we will calculate step 1. Calculate the regression of y on x, calculate the regression of y on x and obtain the residual, which is EI. Firstly, we will calculate the regression of y on x and obtain the residual. The second step includes obtain the absolute value of EI, which is this. Firstly, we have to calculate the regression of y on x and obtain the residual EI. And second step is to calculate the absolute value of EI. Now we will compute DI as rank of xi minus rank of EI. DI is computed as this. The next step include Spearman correlation Spearman rank correlation coefficient. Spearman rank correlation coefficient is given by R, which is nothing but 1 minus summation di square 6 summation di square upon n square minus 1. This is the formula for calculating the Spearman correlation coefficient. Now, the significance of R can be calculated by t-test. Significance of R can be calculated by t-test, where t is given as R under root n minus 2 upon under root R square minus 1. One minus R square. This is the formula for calculating the t. Now we know that if t calculated is greater than t tabulated, which is then we reject h naught. Otherwise we accept it. So h naught here would be that model is homoscedastic. So this completes our Spearman correlation coefficient and our detection methods. Now moving forward, what are the effects that this heteroscedasticity has on our model? So first is, let us consider SLR model, which is nothing but yi is equals to beta naught plus beta 1 xi plus epsilon I for all I goes from 1 to n. So first effect is unbiasedness. The OLS estimators are for beta naught cap, for beta naught it is beta naught cap, which is nothing but y bar minus beta 1 cap x bar, and for beta 1 cap, beta 1 it is nothing but summation I goes from 1 to n ki yi. So these two are the estimators that we have done in the previous lecture of SLR, simple linear regression model. And if you don't know how where it came from, then you can see the previous lecture. So the OLS estimators are given by this, and estimation of beta naught cap is nothing but beta naught and estimation of beta 1 cap is nothing but beta 1. These are the two. Hence, we can say that heteroscedasticity have no effect on unbiasedness. Heteroscedasticity has no effect on unbiasedness. The second property is variance. Now we see that variance of beta 1 cap here is nothing but summation I goes from 1 to k, 1 to summation I goes from 1 to n ki square variance of yi. Now variance of yi in the case of heteroscedasticity would be summation I goes from 1 to n ki square variance of yi sigma I square. And we know that in the simple case, summation I goes from 1 to n ki square sigma square. This is the variance. So this variance is greater than this variance, and hence we can say that our estimator is not efficient. Because the variance is greater than it has to be. Now the third property is testing of hypothesis. Testing of hypothesis. This is the third property. So we know that the t-test is beta 1 minus beta 1 cap upon under root of variance of beta 1 cap. This is the t-test. Now we know that this variance has very large value, and hence t has small value. Variance is large, t will become smaller, and hence t is less than t calculated, which means we accept h naught. But the case is that this test is not valid because the variance here that we have calculated is bigger, which shouldn't be the case, because we have to reject null hypothesis and we have to prove that our model is heteroscedastic. But here, even though our model is heteroscedastic, we are getting that we accept that our model is homoscedastic. So, invalid test. Now, the fourth thing is confidence interval. We know that 100 into 1 minus alpha percent Ci is given by beta 1 plus minus T alpha n minus 2 into under root of variance of beta 1 cap. This will be the confidence interval for beta 1. Now here the value for variance of beta 1 cap is very large, and since value is very large, our confidence interval, see, if the value of the outer side is very large, then our confidence interval also increases. The width of our confidence interval also increases, and hence this confidence interval has larger width, which is not a good sign of good estimator, and hence it also affects confidence interval. Heteroscedasticity increases width of CIs. These were the four effects that heteroscedasticity has on our model. Now moving on further, how would we uh, if our model is incorrect, then we have to apply some remedies to it so that our model becomes correct. So some of the remedies are remedies to heteroscedasticity. First one is transformation model. What is transformation model? Transformation model has sub-classification: logarithmic model, logarithmic transformation model. So in logarithmic transformation model, we will take log of the dependent variable, log of yi is equals to beta naught plus beta 1 xi plus epsilon I for all I goes from 1 to n. Since log of any value is lower than that value, our variance decreases, and hence this is one of the remedies of homoscedasticity. Second is squared root transformation model. Similarly, as we took log, we will take square root of the dependent variable, which is yi, is equals to beta naught plus beta 1 xi plus epsilon I for all I goes from 1 to n. So square root value also decreases the variance of any model. Now the second remedy is generalized least square method. Second one is this. This we use in multiple linear regression model. Suppose we have our model y is equals to x beta plus epsilon. Here, let us consider estimation of epsilon is equals to 0 and variance of epsilon is nothing but equal to sigma. So we will multiply by sigma inverse on both sides of the model. So our model becomes sigma inverse y is equals to sigma inverse x beta plus sigma inverse epsilon. Now this will become y star, this will be x star beta, and this will be epsilon star. Now we will calculate the variance of epsilon star, which is nothing but variance of sigma inverse half epsilon, which is sigma inverse variance of epsilon sigma inverse. Now again, taking variance of epsilon from here, we will get sigma now sigma to the power 1 can be written as sigma to the power half into half. So this will become minus half, 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 minus half. And this will be obtained as identity matrix, which is a constant. And hence our model becomes, our beta cap becomes x dash sigma inverse x IN. This will be our estimator. Now we will find the third remedy. The third remedy is weighted least square method. This is used for simple linear regression model. Suppose our model is given as yi is equals to beta naught plus beta 1 xi plus epsilon I for all i's goes from 1 to n. Now here the weighted least square method, in the weighted least square method, we will consider as estimation of epsilon I is equals to 0 and variance of epsilon I is equals to sigma square xi square. Let us consider this. This is again heteroscedastic model. So we will multiply by 1 upon xi in the model. So our model becomes 1 upon xi yi is equals to 1 upon xi beta naught plus 1 upon xi beta 1 xi plus 1 upon xi epsilon I. So we can write it as y star is equals to beta 1 plus beta naught into xi star plus epsilon I star. Now again taking variance of epsilon I star is equals to variance of 1 upon xi epsilon I, 1 upon xi square into variance of epsilon I is equals to 1 upon xi square into variance of epsilon I was sigma square into xi square, which is nothing but sigma square, which is treated as a constant, and hence our model becomes homoscedastic. So now our estimators of beta naught cap is equals to y star minus beta 1 cap x star bar. This is first estimator, and beta 1 cap is equals to summation I goes from 1 to n yi star minus y bar star xi star minus x bar star upon summation I goes from 1 to n xi star minus x bar star whole square. This will be our second estimator. And this completes our heteroscedasticity. So now we will move forward as we do in our every class to one PYQ regarding the topic which we have done in the class. I hope you all are practicing at home, because this is a hard topic and it is impossible if you don't practice and just see the videos. So I hope you all are practicing so that you can clear this exam. Now we will do one PYQ of 2024, which was of 15 marks. The question says that what is heteroscedasticity? Explain the consequences of heteroscedasticity on OLS estimators, and also explain Spearman rank correlation test for heteroscedasticity. So heteroscedasticity is nothing but you have to explain in the simple linear regression model. Our heteroscedasticity is given by this. Suppose we have taken SLR model where yi is equals to beta naught plus beta 1 xi plus epsilon I for all I goes from 1 to n. Now here variance of estimation of epsilon I is equals to 0, and variance of epsilon I is equals to sigma I square, which is not a constant. This variance is not a constant, and this is the this means that our model is heteroscedastic. Now, the second question says that explain the consequences of heteroscedasticity on OLS estimator. So, since effects of heteroscedasticity on OLS estimators, the one which we have done effects of heteroscedasticity on OLS estimator, first one was unbiasedness. No effect. Second one was variance. No efficient estimator. Third one was testing, invalid tests. Fourth one was confidence interval. Increased width. Of CIs. All this you can do, all this in detail we have done previously, so I'm not repeating all of that again. Then the next question says that also explains Spearman rank correlation coefficient for heteroscedasticity. So Spearman rank correlation test. Firstly, we will take the model yi is equals to beta naught plus beta 1 xi plus epsilon I, for all I goes from 1 to n. Now step 1 was to compute regression of y on x and residual ei. The second step was find the absolute value of ei, that is mod of ei's. The third step was to calculate di, which is nothing but rank of xi minus rank of modulus ei. Fourth step was uh, calculate Spearman correlation coefficient, which is given by r is equals to 1 minus 6 summation di square upon n square minus 1. And the fifth step was test the significance of r, which is Spearman correlation coefficient. And to test the significance, we will calculate T star as r into under root n minus 2 upon under root 1 minus r square. This is our test for significance of r. Now again, if we have calculated if r, this test for significance is greater than tabulated t, then we reject h naught, where h naught states that model is homoscedastic. H naught is this, versus H1 is model is heteroscedastic. This completes our question, which was of 15 marks. I hope you got the question, and if you still have any doubt, you can ask in comment section. We will answer the relevant doubts, and I hope you are doing every day working on this, not only seeing the videos. Uh, Thank you.